of this is to help us all keep abreast of the progress each of us is making, evolve a culture of peer review very early in your career, and also to assist individual researchers by having others make contributions to their work, contributions, comments, critiques, and so forth. So we grow by shared development. Like they say, it takes a village to raise a child, but this time around, it takes a team to raise a successful researcher. So that's the whole goal. So participation is very important, and I expect every member of the group should be present. It's only an hour and a half or so in a whole week, so we should be able to make time. So that is quite important. And so I do hope that all the presenters, I want to thank you all who have presented already. It's not an examination or some job. It is actually just like having a meeting, get together, and discuss such issues. Whenever we're back, physically together, otherwise we'll be able to have additional stuff like some social, some refreshments and stuff like that. But for now, this is very convenient in terms of the fact that we can connect with people across a very wide geographical area, including our colleagues, our colleague in Namibia as well, and Lagos. So thank you very much for coming for the presentation, and we'll have the presenters just proceed and let us have the interesting presentations. Thank you.
Okay, thank you, Prof. So we will proceed. Yeah, let me share my screen. Okay. Basically, this is an impromptu presentation. We didn't actually plan this, but things did not work as we planned, so we just have to put a presentation. Then hopefully by next week we'll have a roster of how presentation is going to be for each week. So this is one of our papers that we just presented in the just concluded. Can you see my screen?
Yes, we can.
Okay.
Are you using the recorded one presentation, or you want to do a presentation?
No, it's going to be a presentation. I won't take too much of our time. Maybe within 10 minutes we should be done with this presentation.
I listened to the recorded version. It was very, very good. So I thought, okay, go ahead. Go ahead.
Okay, thank you, sir. So the title of the presentation is South Africa Electricity Supply System, the Past, the Present, and the Future. It's a collaborative work under the supervision of Professor Davidson, and he contributed immensely to this work, and we are grateful for his touch on this, and that's evident in the review process. The review scaled through because of the way he touched it, and we are grateful for that.
Thank you.
So this work is basically a review of the electricity industry in South Africa, which is undergoing rapid changes and restructuring. So it has been an industrial sector that is sole preserve of Eskom, which is a state monopoly institution. So the liberalization and privatization initiative of South African government indicates a significant change in economic policy, and the collapse of the central planned economics of this world and the rapid development of Southeast Asia economics in the 1980s and 90s have made governments and institutions worldwide to acknowledge the importance of involving the private sector in national infrastructure development and in management. So global trends shows a shift towards the regulation and the introduction of competition in the electricity industry. So this is a means of providing sufficient energy supplies and lower energy prices to end users. So South Africa as a country has seen an emergence of independent power producers as a significant factor in power system planning and operation mix. So this paper addresses this development. So this is basically what this paper is all about. And in background, So as we know that electricity is the key driver of global economy, it is the prime energy source for supplying customers because we can transmit power. It's easy to transmit in bulk quantities over a very long distance. So, and electricity is also versatile. That is, it's very easy to convert from one form to another, and it's very easy to control, at least relatively speaking. So it means that the preferred energy source for serving industry, commercial and residential loads, it is electricity is highly preferred. So the availability of inexpensive and abundant energy is vital to mechanized agriculture, mining, industry in terms of manufacturing, the modern transportation, and human physical comfort. So the organization of society, nations, and social security are dependent on availability of energy supplies. So there is a strong correlation between per capita GNP and per capita energy consumption and standard of living. So energy security is critical to national security. So its availability is critical to economic growth and development. So over the last several decades, South Africa has experienced significant changes in electricity supply industry. So this work is basically divided into three sections. We have a section on generation and load, and we have a section on transmission and distribution, and we have a section on market structure of South Africa electricity system. So each session is considered in the period of in the past. Some people can say in the period of apartheid and post-apartheid, and we also talk about the prospect that is in the future. So adequate power generation is required to meet customers' load demands, or we can say load requirements. So thus, with an increasing population, there must be a corresponding increase in power generation of any nation in order to foster industrialization and economic development. So in the past, for generation and load, municipalities and private companies dominated electricity here in South Africa. So the first public electricity was a coal-fired power plant used to power street lights at night, which was installed in 1882 in Kimberley. So later in 1891, a central power station consisting of 150 kilowatt generator was installed in Cape Town Harbour, which supplied government houses and its environment. So in 1923, Eskom, as you know, that Eskom was a non-profiting company, was established by Electricity Act of 1922 to provide electricity to customers. So by 1948, Eskom bought over the Victoria Falls and Transvaal Power Company for a sum of 14.8 million pounds, and hence became the primary electricity provider to date. So for the present, in 2009, South Africa became the 6th largest producer of coal, with hard coal production of 1,620 terawatt hour in 2019, in 2009, and thus 77% of South Africa's energy needs were derived from coal. So in 2008, South Africa attained a total generation production of 1,995 terawatt hour, and observation shows that energy generated in South Africa increased steadily from the year 2004 to 2012, and the portion is exported to neighboring countries of Botswana, Lesotho, Namibia, Swaziland, and I think Zimbabwe. So from 2007 to 2009, Eskom controlled 95% of power generations with 27 operational power plants, and it provides 40% of the entire African's electricity. So, however, after 2009, with an increasing population, global increase in population, Eskom has been unable to keep its generating capacity up near the population growth, and this is leading to an increasing deficiency between energy demand and energy generated, which often resulted in load shedding that we are experiencing. In fact, that's one of the reasons why I stay at home. I know if I am in school, I know there is going to be electricity a load shedding by 10, and it can affect my presentation.
Okay, we need to move fast.
So the present we know that the whole narrative is changing, and everybody is talking about renewable energy. So by March 2009, the National Energy Regulatory Agency here in South Africa, they introduced a system of feed-in tariff that is designed to actually produce 10 terawatt electricity hour of 10 terawatts of electricity per year by the year 2013. So in a bid to increase the contribution from wind resources and include more wind farms in the energy mix. So also the government launched an auction-based renewable energy power program in August 2011 in a bid to reduce the cost of power. So this reform led to renewable energy independent power producer procurement program, which they call REIPPP, or they can call it REI4P. So this is aimed at encouraging private sector's interest and facilitating investment in grid-connected renewable energy at the lowest possible cost. So these investments cost Eskom about $14 billion and forecasted that the procurement of about 3,625 megawatts of field grants. So the scheme successfully added around 2,458 megawatts of electricity from the proposed 3,650 megawatts of renewable energy inclusion, as shown on the screen. So the current installed capacity of South Africa currently consists of generation option, which are about 39 gigawatts installed capacity from coal, 1.8 gigawatt from nuclear, 2.9 gigawatt from pumped storage, and 2.8 gigawatt from hydro, 3.8 gigawatt from diesel, and 3.9 gigawatt from renewable energy made up of wind, solar PV, CSP, as captured in the figure shown on the screen. So for the future, in June 2018, the government signed 29 new RE projects under the REIPP and plan to add about 19,400 megawatts of new renewable generation by the year 2030. So it is envisaged that renewable energy contribution of national grid will increase steadily, and as such, by 2030, the renewable energy capacity share will be 17.8 gigawatts of electricity, and similarly, the probable replacement of coal-fired generator and nuclear generator by renewable energy resources will be up to a capacity of 9.6 gigawatts by the year 2030. Now for the transmission and distribution. In the past, the Rand Central Electric Work built the first commercial central power station in 1897. This provided electricity mainly to Johannesburg gold mine, and by many of the mines installed their power stations over the next 2 decades, and supply electricity to neighboring towns. So the municipality of Kimberley built its distribution system in 1890, and Johannesburg built its own in 1891, and Pretoria built its own in 1892. Cape Town built its own in 1892 also. So Durban here built its own in 1897, and East London in 1899, and Bloemfontein in 1900, and Port Elizabeth in the year 1906. So the picture that we see here is the Rand Central Electric Works, the way it looked then. So for distribution, the present. So Eskom owns the transmission grid, as we know, and this is responsible for about 60% of, and Eskom is responsible for about 60% of distribution, while municipalities are responsible for the remaining 40% distribution. So we have currently 257 municipalities in South Africa, and they play a vital role in electricity distribution. So this municipality, they are also distributors. They buy bulk power from Eskom, and some also generate a small amount of power for sale in their area. I mean, in their area of jurisdiction. So the table shows the details of distribution infrastructure that we currently have in South Africa. So for the transmission present, the Eskom generates electricity at the power plants, most of which are clustered around the coal mines in Mpumalanga and northern provinces. However, this is not the place where most electricity is demanded. So the big load centers are based in areas such as Gauteng, Western Cape, KwaZulu-Natal provinces. So the power is transmitted mainly through 400 kilowatts network and to these areas that we have mentioned. So Eskom is in charge of physical infrastructure that moves bulk power from generation to different distribution companies. So its HVAC transmission system consists of a total of slightly above 28,000 kilometer operated at standard voltage of 765 kV, 400 kV, 275 kV, and several voltages as listed in the legend. So majority of these lines are 400 kV, and about 325,000 kilometers of distribution lines. So step-up transformer boosts the power as it leaves the power station at the voltage of as high as 765 kV, and it step down at a point for the customers, for the customer distribution at substations near the load centers. So additionally, there is one HVDC transmission connection, which is about 1,420 kilometers long from, I think it's from Apollo Kwara Basa line, which is operating at a standard voltage of 533 kV for 1,920 megawatts power transfer between that hydroelectric power station in Mozambique and the dam also there, and between that place and Johannesburg. So the table shown here shows the details of the Eskom transmission infrastructure. So now for the challenges and the future perspective of transmission and distribution. A mix of aging power plant, unscheduled maintenance, and design flaws in the new Medepi and Kuseli power plants have compared the utility to actually introduce periodic power cuts to give itself sufficient space to restore the system in an emergency. So Eskom is under enormous financial stresses. They are facing claims of corruption and accusation of poor management. So the solution to electricity crisis is beyond just generating power, and we know there's a consensus that electricity transmission and distribution needs to be on the radar for more efficient service delivery. So purposeful implementation of the IRP policy of government, which is introduced in year 2010. The policy is actually a guide from the government to diversify into renewable energy sources with private sectors to generate a particular megawatt of electricity. We've talked about that in our previous slide, and they are to sell back to the national grid, and this will go a long way to meet the electricity demand of South Africa. Then also, we need to onboard Eskom. There's onboarding of Eskom into separate entities would actually increase the efficiency, minimize system corruption. It will break this monopoly and provide power generators with minimal cost transmission system, and it make it equitable for anyone wishing to invest in the sector. Then, lastly, an option to consider as government as government is finding alternatives to resolve energy crisis is the interconnection, introduction of HVDC system. HVDC lines will bring better techno-economic transmission solution as load continues to increase in South Africa and other Southern African development countries. So the load could be interconnected using the HVDC transmission lines with the new and distributed generation sources. So HVDCs can actually connect South Africa with Kariba hydro plants in Zambia, and can also link the DR Congo hydro generation, that is the England dam, to South Africa, so that we can take more electricity from there. Then a lot of analysis has also been analysis have been done in this area to look at the techno-economic viability of HVDC over HVAC system, and HVDC has shown that it can actually technically it's better than HVAC, and economically is also better. So lastly, the economic electricity market structure. The former ESCOM, that one is ESCOM, was formed under the Electricity Act number 42 of 1922. So electricity was generated and supplied at the lowest possible cost. So it had to ESCOM, that former ESCOM had to raise capital by issuing bonds. Although in the early years it obtained interest-free loans from government. So then the profit or loss of ESCOM was not allowed, and the corporate income tax, they were exempted from the corporate income tax. So in addition, the Electricity Act of 1922 also established an agency called Electricity Control Board, ECB, which was formed to regulate energy supply companies. And the ESB licensed and approved its tariff for service of So the ESB licensed and approved its tariff for the service of private generators and the former ESCOM. So municipalities were not provided ECB licenses. So later, the new ESCOM Act of 1987 moved the ECB responsibility for tariff now to ESCOM. So now ESCOM controls the tariff. Then ESCOM used to control the tariff. So at present, for the electricity market structure, ESCOM no longer has the exclusive generating rights in South Africa anymore. So this monopoly power of bulk electricity generation has been broken, and the government has introduced new IPPs, which are increasing their respective market shares. So the integrated resource plan, which maps the projected energy needs and resources of country to meet the demand, help the new generation companies. So renewable energy companies, which have mostly built their power plants under this new policy, they are the new entrants in the energy sector, and the program is based on competitive bid, in which prospective power producers apply for bids, and they are awarded according to different criteria stipulated by the government. So the figure shown on the screen presents the current electrical power industry structure as it stands, and ESCOM dominates the generation, transmission, and more than half of the distribution network. So on the margin, small IPPs power imports into the grid are allowed, and they are sold directly to ESCOM as shown on the screen. Then for the future of electricity market structure in South Africa, ESCOM is recently they reviewed their wheeling charges, which indicate that ESCOM is actually prepared to facilitate third-party access to the grid. So market liberalization, as we all know, that it has happened all over the world, and it's today viewed as being the solution to many problems. A lot of people have said that government has no business in business. So this is the new narrative. So ESCOM is also now developing new scheduling and dispatch rule, which will materially affect how electricity is traded, and it will contribute to clarifying processes around balancing this. So distribution business will therefore be restructured into national distributors of electricity, and the government is expected to unbundle the power supply industry into regional electricity distributors I think I asked question about this when Mr. Chetty, when they were presenting, and this regional electricity distributors, they will be financially viable, and they will be autonomous. They will be able to operate on their own, and they will only just cooperate on issues such as electrification, preparation, tariffs, and central trade. So multiple players will be allowed into the generation market, and government recognizes that competitive model and involvement of private sector will offer benefits to electricity consumers and will lead to national development. So government is expected to launch a thorough study of potential structure of the industry. These are also areas that we can look to for further research. So the implementation of the IPP in the South Africa electricity market structure looks promising, actually, and competitive market provides an investment in incentive framework that facilitates competitive electricity pricing. So the privatization could liberalize the market and allow more IPPs to ensure customer satisfaction. Also, this will offer the requisite production flexibility and reduce the problem of load shedding in the current market. So in conclusion and in summary, South Africa electricity grid has evolved over time. So South Africa accounts for almost 45% of all sub-Saharan African electricity production capacity. So since 1994, access to electricity for South Africans has risen from 30% to 70%, while access remains under 30% for most other sub-Saharan African countries. So peculiar challenges of South Africa electricity supply are identified in this work, and the way forward has been the way forward has been. I think there is a network problem. Can you hear me?
Yes, we can hear you.
Okay. Sorry, I think there was a problem. There was a network problem. So,
yes.
While access, I said access to electricity remain under 30% for most sub-Saharan African countries. So this work, we identify peculiar challenges of South African electricity supply as identified, as we have discussed in our previous slide, and the way forward has also been preferred in this work for generation and load transmission and distribution and electricity market structure. So into a broader context of long-term national energy policies and scenarios, which do not distort the market, the development of renewable energy industries projected to increase continuously. So this will actually allow a stable national power system to emerge based on an efficient energy mix that provides national energy reliability and independence. So the challenges in energy production are critical, and there is a need to declare a state of emergency in this area. So the continuous partnership between the IPPs and ESCOM is therefore encouraged, and this will provide a competitive and complementary approach to meet national energy demand. And this offers various advantages as we have identified in our previous in the course of this presentation. And one, for emphasis sake, this includes diversification of electricity generation and supply, enhancing the capacity, aiding investment, and improving overall efficiency and transparent pricing system. Let me see.
Thank you very much.
Okay. Thank you very much. My slide is no more showing, so that concludes the discussion. Thank you.
Okay, no, thank you very much. Let us open for discussions and criticisms, comments, reactions, and well, let's make it dynamic, because there's many ideas expressed here, and not everybody and not every one of us may agree with that position or otherwise. So let us have any questions. Please just go ahead and raise your hand, or just go ahead and comment. Viren, yes, let's hear from eThekwini.
Yes, hi there. Good morning. Very nice presentation. They said I heard the word allegations of corruption a few times in your presentation. I think it may be a bit dangerous or dicey to put it in a technical study. So
yes, that's right.
We just need to look at that.
Yes,
and also
I agree
in
with
terms of the distribution industry, that's where we come in, being part of the eThekwini municipality, where there's talks of formation of the electricity distributors again. A big concern for Durban, because we classify ourselves as one of the best run municipalities and electricity distributors in South Africa. The kind of distribution of wealth and taking over areas that was previously poorly maintained. So it's just a comment from my side. That's one of the big concerns for us going into such a venture. Thank you.
Thank you.
Thank you very much.
More questions or comments? While we're on that discussion, I have a question. For the IPPs entering into the market, who are trying to gain more market share and all that. Do the IPPs are they ever required to have some moderate experience in system operations? Viren.
Is Mr. Viren taking that?
Anybody? Yeah, you can take that.
I think the government they have the certain criteria involving technical and they look like the capital they have. So I don't know too much about that, but I know they will have certain criteria that they must actually fulfill, because they receive a lot of bids and not all bids are actually successful. So I think they actually look into some of those things, but we don't know how the operators of the system do. I mean, how they can actually influence maybe their friends from getting bid. But I think the bidding has been, from our study, has been very, very transparent, because not all bids are actually successful. So you will look into that probably.
Typically, the one of the challenges that I find with the electricity industry is that is a very different type of market from the regular commodity market. If I buy plenty of apples from the store from a supplier and I need a few and all that, I simply take the ones I can use now, put the rest in storage or otherwise. But when it comes to electricity, you literally are generating and consuming in a matter of instantly. So which does not give you a lot of room for that kind of maneuverability, which is a key identity of most commodity markets. So if, for example, the demand goes up to 2,000 megawatts in Durban, and your supply 2,000 megawatts, if it drops suddenly to 1,800 megawatts, there's no way that eThekwini electricity is going to store 200 megawatts or otherwise. So it does be a dynamic process. So the purpose of my question there is that the involvement of the IPPs in generation simply deals with the issue of the production of the electricity, but the delivery and the biggest challenge, which is the consumer. The consumer is not predictable, or at least the consumer does not demand constant power all the time. So you have your low duration curve, which peaks in the morning and the evening. And so you have to, as a system operator, ensure you match your generation at all times with your low demand in the system. So Viren, whoever is in the industry, what do you advise in respect to this phenomenon? Because some of the IPPs themselves may be based on things like solar power, wind energy, and a few other types of resources. Does eThekwini have any such IPPs around here?
I think they have, but I'm not aware. I don't know their names.
Yeah, is Viren still around? I know Sanjit is not in the meeting.
I think Viren is still.
Yeah, I think it's off.
Mr. Beren?
Yes, anybody else? I mean, most people are studying. I can see that. I think Cindy's online somewhere. I see Ngema
Cindy?
there.
Ngoni?
I think it looks like Colin might be around.
Yeah, I'm here.
Yes, and Ayo is there. Madam Sela is probably okay. Go ahead. Let's hear comments from you.
Yeah, Prof. Mr. Tunji. Yeah, I'm just thinking in my mind this unbundling of ESCOM. I see in the presentation you say it will do with the breaking of the monopoly. So I'm trying to think. I'm trying to think.
My opinions are reserved. So just keep talking.
Yeah, I would have thought that it would be better to have new assets coming into the market rather than just unbundling and maintaining the same assets. So I would say new players, new assets, and we grow the system rather than just unbundling. That's my opinion. Yes.
It's a good one.
Yeah, I think the two are going side by side. Like the IPP, they are also new. They are also new entrants into the system. So that's in an angle. Then also unbundling ESCOM is also another angle. Probably some of the new companies that will emerge from ESCOM will also be able to interrelate with the new IPPs without actually having the ESCOM as the sole entity to relate with. So the two are going side by side, in my own opinion.
Okay,
but
sorry, finish because we have more hands raised. I want to follow the people.
So, but the unbundling, let me just say, in the case of Nigeria, I don't think the unbundling has actually been successful anyway, because in Nigeria they also unbundled the former power holding company of Nigeria, and it has not even improved the situation. So I agree with you in that area, but the new entrants, I think South Africa is also encouraging that. Thank you.
One last thing, Mr. Buraimoh. Your presentation without the Grand Inga Dam and that Ethiopian Great Renaissance, those two, I don't know, the story of the African electrical system cannot be without those giant projects. So I don't know what's your take on those two.
No, I think we mentioned, we didn't mention that of Ethiopia, but we mentioned that of the Grand Ingila Dam. In fact, we need to mention it because Prof has been one of those who are, proponents of that project and making us to have Africa Super. I agreed. I think we mentioned Ingila Dam, but we didn't mention that of Ethiopia. Thank you.
Let's hear from Phakathi. Phakathi can speak. Unmute your mic.
Mr. Phakathi, your mic is muted. Okay.
Yes. Thank you. Thank you, Prof, and thank you, Tunji, for the powerful presentation. Indeed, I can see South Africa is moving towards the positive side of the good future. Just to check, you mentioned that the excess of electricity has increased from about 30% in '94 to about 70%. Looking South Africa with a number of researchers, I believe it will change probably in the next 30 years, around 2050. Are you seeing a possibility that renewables or IPPs will overtake the conventional, that is coal? Is that a possibility? Because I can see we are moving in a very high speed. Thank you.
That's an interesting discussion. I wish we had some more folks from ESCOM systems operation here or transmission to have a better idea. Just remember that the electricity we are producing is serving 3 classes of customers. industrial consumers, commercial sector, and then residential. And the bulk of the electricity consumption is at the industrial level, where probably over 70 or 80% of the electricity is utilized. Residential is actually quite a small component. The question that comes to mind is this: is that these IPPs and so forth, I believe are they required to also contribute to base load in the entire energy mix, or they're just there to serve for peak demands or for limited hours of the day? That's my question.
I don't think they are just there for peak demand. I think there's general consensus that there's shortage. So it's not just for the, I can't really say much about that, but I know that the IPP, they still have to sell to Eskom. It's not as if they have their own distribution system. So I doubt if it's going to be just for peak. I think the shortage, there's agreement that there's shortage already. So I think they have to just be available at all time, because in the towards the end of the presentation, they still generate to Eskom. So it's Eskom and the municipality that actually distributes. So
yeah, the reason why I asked that is that when you hear about load shedding or you hear about power cut, except when you have system failure, typically it's oftentimes due to the fact that demand on the network may be exceeding generation capacity. And that may happen just a few minutes, few hours of the day. And when that happens, you have to take off non-priority loads or do load shedding and ration across many consumers and so forth. But base load generation, at least historically, was rested upon about 10 major coal-fired power stations. While the rest of the other stations, pump storage, gas turbines, and so forth, or saving for peak demands and so on. So one of the things that I'm looking at is that if IPPs come in, let's give an example. You generate 200 megawatts of power as an IPP to put in the grid. Remember, you're not providing that power anytime that Eskom wants it. You provide that power when you have the resource. So let's say for a typical solar power plant, it has that 200 megawatts available. Let me say from about 10 a.m. to about 4 p.m. Let's say if the demand for electricity during that period of time in the network is not very high, Eskom is still obligated to buy that particular supply because of contractual obligations, which means that it has to then shut down or reduce its own generation to keep the network in shape. And then when the next peak demand happens, maybe about 8 p.m. or otherwise, when many of these other, say, for example, solar power plants are not generating, Eskom now has to also meet the demand that is going on. So that's a challenge that most people are not paying enough attention to, that the fact that you supply me apples all the time doesn't mean that I can consume all the apples at your point of supply. So that's something that you should always have in mind or think about. Then the other thing I want to ask is this. Viren brought that up about the issue of corruption. Now, we don't usually bring that up in technical discussions because it is a legal issue. But talking about, let's use a different word and talk about poor management. That's a better word to use. So if we have a situation wherein one utility company is not well managed, I'm curious that if you were to unbundle it and split it up into many smaller units, will it be easier to manage better, or do you just spread out the poor management across many companies? I think Cindy is doing that study right now. Can I? Yes, I see Vasu is there. Okay, thank you. Let's hear from Vasu.
Hi, Prof. Hi, colleagues. How are you all doing?
Very good.
Very good.
Yeah, sorry, man. I had a problem connecting, and then I had a problem with my speakers as well.
Oh, sorry about that.
I just got the last bit of the the presentation, but I couldn't say anything. Then I had to disconnect and restart my machine.
Okay.
But I had on my when I presented the slide, I had a slide that shows the ESCOM's TDP, Transmission Development Plan, which is in line with the national IRP, right? So I've got it up here. I just want to see if I can share my screen with you guys.
That'd be good.
And that graph. So are you able to see this?
Not yet.
Has it come through now? Is still not able to see it?
Not yet.
No.
Not yet.
Okay, let me try again. Share. Are you able to see it now?
Yes, we can see it now.
Perfect. Thank you.
So this is ESCOM's current and future generation plan. So it's also in line. The bottom graph is actually the TDP, what was shared last year, right? And every year ESCOM does a 10-year transmission development plan, which is aligned to the generation plan as well, right? And it's also aligned to the demand forecasting of the country, right? So this is what they had shared, right? So as you can see, that coal is still going to be going into the future will be that base load, and then there would be that increase in wind and PV and so on, right? So even they predicted 40 gigawatts that they say that they could supply. When you have your breakdowns and stuff, it comes right down to around 25 gigawatts at times. So definitely there is a space for IPPs, right? That's the one thing. The other thing is, I'm not sure, I might have mentioned it in my presentation as well, about the C40, and a lot of municipalities aligning with C40 to lower carbon emissions and keep below that 1.5 degrees of temperature rise, right? Which means that basically, at eThekwini, we've done our resource plan, right? Integrated resource plan, and our targets are to have renewables contributing to around 30 to 40%, right, of our consumption by 2030, and which is ambitious. But even more ambitious is the fact that the target also says that we should be 100% of renewables by 2050. So definitely there is a place for renewables. In terms of our IRP, a study was done for eThekwini, right? And it's more likely that we won't have IPPs coming within eThekwini, right? We've got the smaller scale guys like your malls and stuff, but large scale renewable generation would take place outside eThekwini. That's what the study says, and then that power would be wheeled in through the transmission network into eThekwini. So that's the only way we're going to meet those targets that have been set.
Thank you. Yeah, thanks a lot. Yes. Any other comments, please?
Yes, sir.
Yes. Go ahead, please. Thank you.
Good day to everyone here. I want to respond to the question that one of the earlier guys mentioned, that is it possible for renewable to to take over from coal. Just like what the last man that commented said, the agenda of the Nestra or the act is to have about 30% of the total consumption generated from renewable energy by 2030. As of 2018, we have a total energy capacity of 51,000 megawatt, and coal or thermal energy is generating about 47,000 megawatt, while renewable just there by around about 3,800 megawatt. So you see that by 2030 is just a few years from now, and we can see that is a tall ambition to get to 30% of total energy installed capacity, which is about 52,000 megawatts, and now we are just there around 4,000. So I think it's just a vision that the government of the day have keyed into, because when you look at statistics, China is leading in the world with renewable energy. They have about 175,000 megawatt capacity, and in Europe is Germany that's leading. Germany has about 45,000 megawatt renewable energy installed capacity, and yet the renewable energy, despite the fact that Germany is leading, that's not the core of their supply. They still use but all that, I think the government agenda is aiming is to reduce the carbon footprint so that we can save our world and we have a cleaner environment. And so I think that is more of the agenda, and renewable energy will not definitely be replacing our conventional coal generation. Thank you.
Right. That's a very important point. Thank you very much, Shine. That's a very important contribution. Yes, one of the things that I want to suggest as an activist is that the government should have a policy that for all generating new renewable energy generating assets, they should be locally sourced or manufactured with at least 80% local content. What do you think about that?
That would be a good one. At least you provide employment, and that we are looking now at the economic side of it. That can only be pushed at the parliament. Just like you said. Now we are talking of activism now, not the technical side of it. So we can only be pushed through the parliament and say, okay, just like we are producing vehicle here in South Africa. So, and you are not allowed, if you are in a South African, you are not allowed to import a used vehicle from Japan. So, and that's the norm. So if a legislation is passed, I think that is very visible. That we have
why is there no proposition to do that? Or why? Maybe I should ask the question the other way. Why is there very limited mention of the need to actually add value to these projects? As you rightly said, if we are patronizing these imports from Germany or China, then of course we are creating the jobs and the economic growth in those countries.
Hi, Prof.
Yes, go ahead, please. Let's open.
As part of our IRP, that is mentioned in our IRP that there should be a large percentage of local content, for most of our renewable projects. Also, another thing that I think on the last speaker mentioned about saving the planet and so on. It's coincidentally that eThekwini had launched a climate action plan yesterday. I'm not sure if you guys were aware. So you know, it goes back to our last mayor signing the Paris Agreement, you know, to adhere to these climate change targets. So, you know, there is that political will as well to actually, you know, conform to these targets. So, yeah, we just got to wait and see, and, you know, how things pan out. Also, you know, but yeah, we also need the national regulations, you know, to also come in. They have said that, you know, municipalities can buy from IPPs and so on. So that's one thing, but there's no guidelines at the moment how this purchasing would take place. So we can just you know, look out for that and see how that pans out. So the climate action plan is quite interesting for you guys to actually look at. It was launched yesterday. They had the mayors and of quite a few countries. They had the mayors of Los Angeles. So it's quite a big thing, and there's a lot of political will, you know, as I said before, in this. You can search it up online, the Durban Climate Action Plan, and you should be able to view that recording.
That's very good.
Okay,
Yes.
Prof, your point of sourcing the materials locally.
Yes.
The question would arise is, then it would come to manufacturing. Do we have the capacity? And it also comes to us as this group of researchers. Do we have like patterns of things that we think we can design for manufacturing?
That's a fantastic point. Let me take you back in history. Let me just take you back in history. In 1960, South Africa was superior in development to China.
Yes.
Despite the whole problems about apartheid. Capacity, South Africa also produced, was the first country in the world to produce synthetic fuel from coal and not from petroleum and all that. That's your Sasol today. It's still there. It's still there. You know,
yeah, so
Dinel exported, you know, fighting choppers to the US. So when it comes to the issue about do you have capacity to generate, to produce or manufacture or not, the question might be, do we have any incentive or commitment or drive to actually try to be, more productive? Because a number of the renewable energy projects are driven by bankers, marketers, and journalists who do not really carry a comprehensive study of the impact of these projects. For example, when you have to carry out your maintenance, though in the area of solar PV is a very simple maintenance, do we produce all those converters or inverters locally? Do we do the servicing and maintenance of these facilities internally? So from an operational point of view, there's a more holistic problem to deal with. Although right now nobody's worried about foreign exchange because it seems it's always there. But if you have a trade deficit that is growing rapidly, you may see a free fall of the currency, and there's a lot of problems. So exports must always be on our minds while we're also talking about imports of machinery and other equipment. That is okay. But I'm saying that if we, for example, it's not difficult to establish a solar PV manufacturing plant. It's not complicated. It's not as complicated. The ones that were tough were the things like the three-phase synchronous machines for bulk power generation. These are massive equipment, which are still feasible. You know, so I'm just asking this question because one of the things affecting ESCOM right now, you keep hearing about the issue of maintenance. What that means is this: when certain facilities are faulty or need to go into replacement or they break down and all that, there's limited local capacity to replace those assets or components as quickly as possible. And there are some of these materials produced within Africa itself by local companies, which are not patronized. So what I'm saying is that it's important to educate our politicians too and leaders that if you don't put the demand on people to be productive, or the people not committed to being productive, you sit back, sell your raw materials, and find quick forex. That's not how a country. That's not sustainable. That's not sustainable. So if you produce all your solar panels here locally, even if it costs more than the one from China or Germany, I'm ready to buy it because I'm supporting local business, getting people around me employed, so they won't come and rob me or attack me because of wealth inequality. So just some thoughts that we should put in some economics into the details. We built simple inverters those days in 2004. No, they were not too sophisticated, but they worked. We tested them. And if we had continued doing that for the last 16 years, I'm sure by now we'll be able to put the same ones that are in the market right now. And these are produced by folks who are not as smart as any of us here. So that's a concern I have, that when you're talking about all these policies and all that, like is it Chetty that brought that, Vasu that mentioned that right now. What part of these projects are supported by local industry? Because you don't just sign free trade agreement. You don't sign a free trade agreement. You can't do that. I can't find a free agreement with you that you can come into my house and out anytime you like. I can't do the same with you. There are restrictions. Maybe you can come in at any time or otherwise, but there's some control measures. So these are just my thoughts about some of these issues. That we provide our base as markets for international trade, but what are we exporting as finished products? Why will a company like Adebiyi, for example, be talking about a crunch when you have a massive economy in South Africa and across Africa that has demand for steel every day, every time? It's market dynamics. Let's think about that as well, not just the technical only. But remember, for any trade deal, tenders and all that, the middle people and the bankers and the finance people and those guys, they are the ones who take a chunk of all your profits and so forth. Anyway, sorry, that was just a comment. Please share your views and share, what do you think about it? Very important.
Yeah,
I think enough of this. To mention this stuff right now. In many countries where you have done unbundling, frankly speaking, the electricity prices have gone up. But it's not because unbundling is bad, but it's because the conditions that created the problems and need for unbundling are still there. If it's mismanagement, if you mismanage one company and you break it up to 10 companies, then you mismanage 10 companies. But it's easier for transparency to see what's going on in 10 companies than to look at one that is bigger and you don't see what's going on. I agree with that. Anyway, that's my opinion. Let me hear from Cindy or from other people. I know that Cindy is doing a paper on this right now. There's Ayo there. Shine, you are still there. Let me hear from you guys. Yeah, so yes, go ahead. Let me keep quiet. Let somebody else talk. Yes, go ahead, Sunji.
Okay, I think, Prof, you've really said it all. You've said it all. The problem is leadership. You were talking about how China grew over time. I think they were just radical in their approach. Like we definitely make mistakes, and the fact is that if we are manufacturing something here in Africa, we can never compete with people manufacturing in Asia where they have the technical know-how, the cheap labor. So the competition is definitely going to be a problem.
Let me respond to that very quickly. It's very simple. Okay. Let me respond to that very quickly. When I was a child, we used to have this phrase, when we buy radios and other things, they are Philips from the UK. They are fantastic and superior. When we buy those ones from China, they break down any moment. We used to call them made in Taiwan. But after 40 years, after 30, 40 years, they produce those things of the same quality now and much cheaper than the one from Europe. And so naturally the Chinese, so that's the point I'm raising, is that people improve in their production. But this is President Julius Nyerere of Tanzania those days make a comment. He said that you do not talk about a free market enterprise as a realistic economic policy. I tell you how let me use a different description. If we have a sporting activity, that's a very good one that is very easy, boxing. You don't say that boxing is a free enterprise sport. Otherwise, Anthony Joshua will kill everybody below his weight division. Are you getting logic now?
Okay,
if you
sir.
put him in the ring with a featherweight boxer, he will only need to throw one punch, and that guy is knocked out. Why? Because there are different weight categories. So the same way, if you are dealing with different markets and different countries and players, you should have some economic protection for certain areas of your economy and areas that you want to, seek that international or external support. You open them up for folks to come in. So you may say, for example, I won't allow importation of eggs. Why? Because our local companies that can produce eggs here, and I want to protect them from imports from Zimbabwe. If they bring in all the imports from Zimbabwe, I can't sell my local products, I go out of business, unemployment, and there's a problem. So that's the point I'm raising. So it's not an issue of African development, because remember, I know you say, we were not even there at the time. In 1958, Gold Coast, Singapore, Asia, all these countries were at the same level of development. So I agree with you, it's leadership, but leadership has to start from somewhere. We have access to good resources now in terms of information. And, I want to see us begin to do work that we are looking at spin-off companies that manufacture or produce solutions or provide, consulting services, But, if the leadership does not even understand what I'm talking about, people can only tell you what they know. Yes, let me hear from Phakathi, please. Yes, somebody. Speak up, please, go ahead. I see a hand up. Is that Phakathi now?
Thank you, Prof. No, it's me. Prof, thank you very much. It's an eye-opener what you have said. I mean, it's really nailing on the dot. Looking rainbow, I mean, producing meat from chicken was very easy, but they were able to close, and then we are buying chicken now from other countries. Why I'm saying this?
I worked in rainbow farms before.
Yeah. But why I'm saying this, because I mean the issue of chicken is simple. I mean you can just grow, I mean it and produce it easily. But why I'm driving to is that I mean it's more about management, about leadership. So even with us, I know at this stage it's difficult. If you tell me just to design and produce a dynamic voltage restorer, I mean I won't know where to go. I mean it looks difficult. But I believe with this information that we're getting from people like you and the other people, we can come up with something and then we can produce these things here in South Africa. I know for now it's difficult, but my point is it's not about the difficulty or the less knowledge about producing things like the inverters or DVRs or whatsoever. It's about management. As I make an example about the chickens, it's simple to produce, but it's not happening. Why? Because of the management. So somehow, maybe one day Mr. Phakathi must be a minister of energy or whatsoever, and then I'm sure things might change. Thanks, Prof.
Yeah, yes, I deeply appreciate that. Let me put it this way. It'd be wonderful to see that over half of our researchers become entrepreneurs. Why is everybody quiet?
It will do something to the GDP of the country. I believe so.
It will. You see, you raised that issue about rainbow chicken farms. In 1994, 95, I worked in that place in Worcester, in Cape Town, raising those poultry birds. And I was involved in an energy study to introduce, we use different brooders, LB White, Ambirad, and the pancakes and so forth, breeders, just to hit the heating elements, the chickens move around it and keep the whole storehouse together, feed them, and all that and so forth, keep them healthy and all that. And then, of course, they grow from a small bunch as they expand the access area as they grow bigger to avoid too much crowding and so forth. We grow the chickens then and so forth. To hear that, it's not going out of business and so forth is shocking. And that you have to now have imports there. So I'm saying that whoever made the laws or agreements that you want to open up critical areas of the economy to international competition is not a good economic policy, because when you have unemployed people who then attack you or attack your house or on the streets every corner, is your problem, not your international supplier or whatever. So my point is that we should begin to think in that holistic context about sustainability. Sustainability. I even grew chickens myself as a single adult when I was a lecturer. As a hobby. I had space. I grew about 25 of them, but I couldn't eat them because I wasn't ready to sell them. I didn't know how to market. Yes. Yes. Yeah. But right now, if you ask kids, where do you get milk from? I know you get it from Pick and Pay or Walmart. You don't know how to milk cows. They don't know how to do any of this thing. So maybe, yes, I think I see somebody's hand up. It's a free discussion, folks, please. By 10:30, we'll need to wrap up because we have job interviews for the department. Yes, let's see, is Ayo online? Is Cindy online? I see people there, but there's no voice. So management is critical. Why is it that? Maybe. Why is management a problem in Africa? It's a question I'm wondering about. We have plenty of MBAs around. Phakathi, what is the problem with management or leadership in Africa? What's the problem? Or is it a genetic problem?
Prof, I think our background it contributes a lot. Because, I mean, we grew up in a very poor background, I mean, so to say.
Oh, no.
And then...
That's the best condition to become a good manager. Because you're constrained. You're resourceful.
Yes. What happens then, Prof, I mean, if I grow up the ladder, then I get few thousand rands whatsoever, then I shift my focus in thinking for the future, but I think for the now, that's what happens with some of us. And then we've got lots of things that we have to attend rather than, I mean, investing on the future. I believe that's where it stands in my analysis.
No, that's a very good point. But the question is this, and this is what I want us to think about. If I join the gravy train right now and get fast money and so forth, what happens if 10 years down the line, all that money dries up? We return back to the bungus again? You get the logic?
Yeah, well, yeah.
You get the logic. So there is no excuse for not looking at a sustainable future because of the current needs now. If we have survived under tough conditions, why can't we focus a lot more on a sustainable? Okay, let's get a good example. How many of us here in this discussion have a 50-year plan? 50-year plan. In 50 years, where do you want to be? Not that you'll be retired or granny or something, no. But are you going to be looking for old age pension, or are you going to be asking Ramaphosa for benefits? So what are you doing towards that plan? Don't we have any ladies in this meeting? I thought Namla was in this meeting.
I think they're having load shedding on campus.
Oh, okay. That may even affect my meeting because I have a meeting for interviews, and I'm just hoping that we have power supply. But I want to thank you all because this has been a very good discussion. But I want also what Phakathi said is something to think about. Is that those are realities? But my concern is that we are heading to a stage now. Let me make a statement. If the rand, the exchange rate right now, let's assume is 1 to 20. 1 to 20, eh? If that figure changes to 1 to 200, what is the impact on our economy? And that can happen. And that can happen. Now you're laughing because you know what I'm talking about. That can happen. So if you dry off coal and you can't export it because there's no demand for it and all that, and you're not even manufacturing the chicken you are eating, then you and I may end up cutting grass to eat in the bush. So I want us to begin to look at bringing a strong element of entrepreneurship into our research projects, economic thinking. So like Buraimoh raised in a very important comment there, we don't use phrases like corruption in technical presentation, but we use the word, we can use the word management or poor management. Those are very smart ways because the word corruption is a legal term for a crime. But the word poor management is a technical term for the same thing without pointing fingers. It's fine. But let me see who will come up in the next presentation to talk to us about the economics of power generation and who benefits. If you all bring in the IPPs and everybody else, and the price of electricity now is 20 cents per kilowatt hour, I can't afford it. So that's why you say there's flow, there's water everywhere, but there's no water to drink. So it's important. All right. Elutunji, over to you. I think I've said enough.
Okay. Thanks so much, Prof. And thanks so much for other researchers for the contribution.
Just a quick one. I think Ngoni and Phakathi have said they are going to start building DVRs and all kinds of controllers. We'll be hearing more from them about their design and their implementation.
Yeah, and the challenges.
Yes, Professor, yes. So I've always longed to do that.
Yes, it's a good thing. And they will get Vasu and Viren to make sure they use the ones we produce and test them. We've never had a discussion like this, but what I'm just trying to emphasize is that the university is saying that we should move on with research, innovation, and entrepreneurship. So over the next 5 years, our research group and department will create companies that produce stuff that employs and generates income. That's where we're going. And you know how I want to do that? It's very simple. If you can push half of your postgrads who are graduated to become business leaders, they will be sending us 1 million rand every year or more to just be a drop cash on your pocket. I was in Virginia Tech in the US. That was back in 2003, thereabout. A postgrad who did his PhD from Taiwan donated and built the entire faculty building because of his business profits from his PhD patent that led to a big spin-off company in Korea. And as a gesture of goodwill, they had a development project like we have now in DUT. He said this faculty building here, it costs about 50 million, I'll take care of that and contribute that to the university. That's it. So that's why I say that your success is my success. And and vice versa. Okay, I think I should let the meeting go now. Elutunji, over to you and wrap up, please. Thank you.
Okay.
Very good, good chat.
Yeah, we still have 2 more presentations.
Okay.
This is the next presentation is by Mr. Philani Ngema. Is going to be presenting his proposal for his PG2. So, Mr. Philani, please go ahead and share your screen.
Thank you, Elutunji. Greetings to Prof and our fellow colleagues.
Yes, very sorry, please. I didn't know you were going to present. Sorry about that.
Thank you. My presentation it's about the dynamic behavior of a percentage differential protection on a power transformer. I'll start from the content. I will just cover the objective issues to be addressed and electrical layout, substation layout, power transformer principles, and phase shifting, and its percentage differential protection on a power transformer and the outcome at the end. On the objectives, mostly the differential protection, it has the issues on the cities, which are city areas. We have to make sure that the city areas are being calculated correctly and selected correctly, mostly on the tape changers and zigzag transformers. Now, on this research that I'm going to cover, I will do all types of transformers, but the practical work will be done on the power transformer only. Although I will do the research in all other transformers on applying the differential protection, especially the differential, because there are other differential protection types on a power transformer. So the first point is to ensure that the CT performance on the differential protection is accurate and correctly, so that we will not experience the errors caused by the CT's current transformers. Then the magnetizing current in rush, of which it's one of the big problem that is caused by the energizing of the transformer. When energizing the transformer, they only to find that the relay sees the fault, because the magnetizing inrush current, it's very high. It's about 8 times the full load current. So it's one of the issues that need to be addressed on how to make sure that the relay is able to see that, to differentiate between the fault and the inrush current. As we know that the differential protection, it only has to respond on the internal, not external fault condition. It has to restrain when it's an external condition. So the determination of the pickup points, which is a pickup current, also has to be determined according to the dual slope, which is the the slope that determines whether the relay has to restrain or the relay has to operate. Also, we have the harmonics, which also affect too much on the relays. The harmonics, like the relays has to differentiate on the type of harmonic. Like the second harmonic has to ensure that there is no operation. It has to block the operation. Like the second harmonic, it has to restrain the relay from operating when there is a fault. Then also going to the fault classification on a differential transformer, of which it's the main cause. The question will be how to ensure that the relay sees the difference between the normal condition and the fault condition are one of the questions that need to arise on this research, and distinguish between inrush and the fault current. Also to prevent mal-operation, like unnecessary operation, and detection of the fault and restraining from the external issues, and ensure the speed and the sensitivity of the internal fault. When it's operated, it has to be very quick and be able. And the other one that I've never added here, the relay has to ensure that it's secure the fail-safe of the circuit breaker. Let's say the circuit breaker is not operating, there should be the signal that comes back to indicate that the relay wants to operate, but the breaker is not responding from that. And also one of the issue that I want to address on this research, it's transformer monitoring oil. As much as we have the glucose relay on that one, however, I believe that we should have another protection of the oil on a transformer. The relay itself, it has to have a way of indicating of seeing the level and indicating the relay whether the oil, whether the oil is it's good state and it's not hot. It's all right to perform the as the oil is for the insulation and also cooling of the transformer. Then with this research, I've approached the one of the mining company in KZN, in Mthandeni region, which is Tronox KZN Sand. They said they can give me their property to implement this one with the SEL. With the SEL release 787, which is -2, -3, -4, which is the latest version of the release tab. Then they gave me 4 of their transformers. Well, I would say 2 because 2 are similar and the other 2 are similar, which is 100 MVA, 132 coming in, then the output is 33 kV. 100 MVA 2, and then 20 MVA the other 2, which is 132 kV to 11 kV. They said they want to upgrade their existing relays into the latest version, as their existing version it's one of the old version which was implemented in the early 2000s. Then on the phase shift and then the dual slope, what I'm going to be focusing on here, it's the transformers are having different phase shift. Then those phase shift, they tend to contribute too much on the unnecessary tripping of the relays because it is not compensated very well. It's one of the study that I'm going to be also looking at the phase shifting, how to compensate the phase shifting, as some of the relays, they even require the interposing cities. It's one of the study that I'm going to be broad on and looking at different types of the relays, and also including the tape changing system. Parameterization, that's one I will also go for training with the test the relay and visit the Squatter SEL company or that one. As the presentation shows, the harmonic restraining diagram with the harmonic bias, through bias, restraining coils and operating coils, and also the dual slope showing the unrestraining pickup, operating condition, and the restraining region. The outcomes is at the end the project will be implemented. The Tronox expect to see the accurate operation, not this operation that is keep on happening in their plan, because now they facing the problem where the relay is just not restrained from the external fault. It's operating when one relay is as the transformer. It's one of the major equipment into delivering the power into the plant, and also the furnaces that they have, the furnaces. If one relay picks up the fault, it just, whether it's internal or external, it just operates. It's one of the outcome that they are expecting to see, and I myself, as I'm working on this one, I'm expecting to make sure that this is delivered accurately, and the relay, it's operate the way it's supposed to operate without affecting other equipment. It operate in its region. Smooth power delivery with no nuisance trip. The differential protection should maintain its requirement as the one of the requirement. It has not to trip from the external operation, and safety operation with it does not impose the risk into other equipment and personnel who are around. And also the insight on the percentage. Thank you. If is there any question, I would like to have them and answer them.
Okay, thank you. Thank you, Mr. Philani. Do we have any question for Mr. Philani? Mr. Ngoni, Sindisiwe, Mr. Phakathi. Okay, Mr. Ngoni, can proceed.
Okay. Hello, Mr. Philani. Thank you for the good presentation. I was just following your presentation. It sort of looks very wide. You're starting off with the transformer protection. then in the end, your outcomes are talking about differential protection. And also, but I think it will be very interesting. It's a very interesting topic. I would be very pleased to see the progress of your research, especially when you mentioned that you're trying to do something like incorporating the oil part of the transformer into the protection relay. I understand you're still in the beginning stages of your research, but yeah, I would be very interested to see what you're going to come up with there, because as is already, the Bukos relay is one of the simplest but very efficient piece of equipment in terms of transformer protection. So yeah, that's my input. More of a comment than question. Thank you.
Okay, thank you. Thanks so much, Mr. Ngoni. Cindy, any question? Mr. Ayo, Mr. Viren, Mr. Mbambai, Mr. Phakathi? Okay, Mr. Philani, thanks for the presentation. Yeah, but you didn't identify the aim, the single aim of this research, and how your step-by-step objectives relate to that to those objectives you listed on your slide. So I would like you to first respond to that. So what's the aim? Then help us link the objectives to the aim.
Oh, okay. Thank you, Elutunji. Well, the aim is to ensure that the differential protection is able to protect the transformer. It alone, it can be able to do protection on inrush current, and also looking at the overcurrent caused by the excitation and so on, and also looking at the fault classification. It is able to pick them up, but without affecting the external fault. Like if there is an external fault, it has to restrain without operation. Yes, there is a study that was done, but what I'm looking at, how quick it is, and comparing on the present study, is there, like on the inrush current, is there a way that it can indicate that this is an inrush and that inrush is at this level, not just to restrain when there is an inrush, but it has to indicate that this is an inrush and this inrush is up to this level. Then from this level, it has to treat it as a fault if it's more than the expected or normal calculated inrush current.
Sorry, Mr. Philani. What happens, the inrush, the characteristic of the inrush condition is a startup. So yes, these numerical relays that you mentioned, they have that ability to know, to pick it up already. Because inrush, that doesn't happen in like, what do you call it, in a running condition. It's only a startup, that's when we do have that inrush. And this, most relays do have that restrained ability. You actually specify it. You want it for how many cycles, how many milliseconds. Then beyond that, it will start treating as a fault.
Yes.
Yeah. Then how often do we have magnetizing inrush current on, like, I mean, compared to faults? Because the way Mr. Ngoni is saying now is only when you just maybe energizing the transformer. That's when the case of magnetizing inrush current comes in. So how often do we have it compared to when normal faults, maybe transient faults in the system?
I agree with Ngoni. He is very much correct with that. The inrush current is expected from the energizing of the transformer, of which as we are facing the load shedding, the energizing of the transformer, it's now and then, time to time thing that is happening because of the situation that we are facing. So after that, Tronox is having one of the critical thing, which is furnaces. If they are down for a long time, it become a huge problem. So power is a demand to them to ensure that their furnaces in operation. So when you energize the transformer only to find that it keep on tripping, then there, at the end of the day, the management will say no, take it down for 8 hours and verify the problem. They only to find that now their furnaces now it's starting to cry and say no, I cannot be done for such a long time. The reason why I want to do this study is to eliminate that problem into their system.
Okay. Okay, thanks so much. And then on you mentioned the issue of harmonics. Maybe you talked about harmony. I don't know the order you were talking about, but now can you help us elaborate on harmonics and how it relates to differential protection, differential currents, whatever?
Harmonics, it's one of the other issue that is caused by the high current on the system, then where you ended up having as we have the normal frequency, which is 50 hertz, having the frequency being raised up by that number of harmonic. If it's 10 harmonics, it's a normal frequency times 3, then it's become 150, and it start to affecting now the relays, because the relays is seeing now the current shooting up caused by the harmonics. Then we have the restraint called to the restraint blocking harmonic, of which it's responsible for blocking those harmonics, so that those harmonics will not affect the relay into its mal-operation, operating without unnecessary.
Sorry, Mr. Philani. At the moment, what kind of furnaces are you talking about? What kind of furnaces? What are they? And what size of the transformers are they operating on?
It's 100 MVA. The furnaces are the DC furnaces. These ones they feed the thyristors, and the thyristors are rectifying the AC to DC toward the furnaces. However, the thyristors cause a lot of harmonics back to as we have also the power factor correction system to ensure that the harmonics are not affecting the transformer that much.
Okay, thank you.
Okay. Lastly, you talked about phase shift problem. I think that's in your objectives. No, okay, in the outcome of the research, you talked about a phase shift and dual slope. So how do we compensate for phase shifts?
Oh, okay. In order to do the perfect compensation of the phase shift, firstly we'll have to understand what phase shift are in that power transformer, and then we make sure that if it's a star delta, let's say it's a star delta, the configuration on a star side, we'll put the delta configuration on the CT similar with the secondary side, and on the secondary side we make the star one, or else we use the interposing CT. we can put star in both sides, but in one of the output, then we put the interposing CT to convert the phase shift, the phase angle to be similar with the other one, so that they will make it the cancellation.
Okay. All right. Any other question? Any other question? So in the absence of question, we'll move to our last presenter for today, in person of Mr. Phakathi. Is going to be presenting. It's just a progress report. We're looking forward to learn from him also from his presentation. Okay, thank you, Mr. Philani. Thanks for your time. So, Mr. Phakathi, you can please share your screen.
Good morning once more, and thank you for the opportunity to do the presentation. I'm Mthandeni Phakathi, under the supervision of Prof. Davidson. I'll be presenting integration of microgrid into eThekwini Municipality Rural Settlement. This will be my scope points. I won't go through them. We'll look at them as I present. Going straight to the background, municipalities are having challenges in meeting electricity needs. Renewable energy has been established as the environmentally and economically solution by reducing the carbon dioxide emissions. In order to efficiently integrate renewable energy to the grid, the concept of microgrid has drawn significant interest. Research problem and aims. Technical development and population growth have resulted in over-dependence on electricity. In the first presentation that we had, we did see that indeed there's been an increase of depending on electricity. As the presenter mentioned that, I mean, looking about around 1994, it was about 30%, but nowadays it's about 70%. And looking, for example, this time of load shedding, when we are hearing of stage 8, everybody's panicking. Everybody is getting frustrated because indeed it's difficult to live without electricity. Concerns over global warming and lack of conventional energy have led also to the consideration of the use of renewable energy sources. The aim of the study is to explore, understand, and find solutions to mitigate unplanned or unwanted outages or power failures experienced by eThekwini Municipality Rural Settlement. The objectives of the study are as follows: to obtain data and model a typical eThekwini Municipality Rural Settlement distribution network, to investigate the technical challenges caused by these failures in the modeled eThekwini Municipality Rural Settlement distribution network, to develop the distribution network into a microgrid with optimal integrated photovoltaic system to mitigate the potential technical challenges, to investigate and mitigate the impacts of the integrated PV system on the eThekwini Municipality Rural Settlement distribution network, to evaluate the performance of the integration of microgrid into the eThekwini Municipality Rural Settlement distribution network. If you look on this area, this is the area where the study is intended to be conducted at. The area is at Lovo, the area out of Manzimtoti. This area is an area of about 70 houses in a rural area fed by one transformer, which is 100 kVA with 4 circuits, one feeding towards this direction, the other one feeding towards this direction, the other one feeding towards this direction, and the other one feeding towards that direction. Literature review. Previous studies indicates that providing electricity to rural settlement causes various challenges, both for the municipality planning and the electricity authorities. Standalone and grid-connected systems, such as hydro, PV, wind, have been previously considered for rural areas. Previous studies show that most of the failures in the networks are the results of overloaded situations. This is just a typical diagram showing an integration of microgrid to the grid in order to feed the house. Research methodology. The research paradigm of design science research is selected. It's just because, it's focusing more on science and engineering and on problem solving. That's why this paradigm has been selected. The research methodology shall include data collection of parameters of typical distribution system in eThekwini Municipality Rural Settlement, consulting some books, and also the use of Retic Master software, and also just to study and utilize the OMA software as well, as it will benefit the study. The study will be done, as I mentioned, at Elovo, is a rural area out of Mthandeni. The plan of research activities, this is just my plan. And then the chapters of this research will be as follows. Chapter 1 will focus on the introduction of the study, which shall include background, problem statement, research, aims and objectives. Chapter 2 shall focus on the literature review and theoretical framework. Chapter 3 shall focus on the research methodology, which shall include research approach, data collection method and data collection processes, data analysis procedures. Chapter 4 shall be the data presentation and discussion, and Chapter 5 shall be the conclusion and recommendation. I should also mention that due to COVID-19, the protocols that have been put forward by the government will be adhered to, meaning that when I'll be visiting the site for interviews, I will make sure that I do have extra masks with me to provide those who might not have. And then I will also have sanitizer to make sure that we adhere to the protocols of COVID-19. I've just selected some few references that I've used. There are a number of them, but I just selected few for this presentation. And that concludes my presentation this morning. I'd like to thank you all. Thank you.
Thanks so much, Mr. Phakathi, for the presentation. I would like others to ask questions. Mr. Mbambai, any question?
Yes, good morning again, everybody.
Good morning.
Morning, Mr. Phakathi. Just on the software that you intend to use, I see you are going to use Retic Master and also do a bit of read up on Homer. I think it would also be beneficial to you if you maybe use the Herman Beta software also, which is Excel based. I don't know whether you've whether you have access to that as well. I think it will also add value to your research, since some of the parameters in terms of rural settlements are already available in that software.
I really appreciate. Thank you very much. I'll look onto that. I mean, thank you very much. I appreciate for the input.
Okay, Mr. Mbambai, can you just maybe type the name of the software in the chats in the conversation page of this meeting so that we can make reference to that. The name of the software is talking about.
Okay,
Thanks
I'll do
so
so.
much.
I think I have it as well. I'll just send it through because it's actually a free sort of free to use software. Yes.
Wow, that would be nice.
No, we really appreciate it. Thanks a lot.
Thanks a lot. Yeah. Cindy?
Yes.
Cindy, okay, any question?
No, I would like to know if because now when you gonna be using PV, I guess you said you're gonna be using PV for your study.
Yes. Yes.
Have you already selected the land in your location, the PV installation?
Not yet. Not yet. Because currently I'm busy with eThekwini, as maybe you heard, Prof. I mean, there's a letter that they wanted. So the area that we've selected with the guys of eThekwini is not finalized yet. I still have to get formally and approval from eThekwini to do the study about their area.
Secondly, the capacity of your PV, because I guess with municipality or ESCOM, maybe I should first ask whether your installation would be grid tied or not. Then if it's grid tied, what voltage are we looking at? Because as it goes high, then you have to follow the code the grid code for integrating your solar PV farm. So can you please clarify on that, like the capacity, the voltage, what are we looking at? I don't know, maybe to answer many questions.
Okay, thank you, Cindy. One, it will be grid tie indeed. I mean, it will be integrated to the grid indeed. And then two, I'm looking as seemingly eThekwini now, what they are doing, they've got 100 kVAs and 200s. So most of the areas, in the rural areas, they've got 100 kVA, I mean, the transformers. So we'll be looking at the 400 volts. We are looking on the low voltage, not on the high voltage indeed. So it will be 400 volts.
Okay, so in terms of protection and everything, are you gonna be doing that yourself? Because now when you're gonna be integrating in their grid, as we all know that the availability of the sun is more during the day, and in the night it will reduce. So are you gonna be able to like cater for that, or protection or control, so that it won't disturb their feed, the municipality feed?
Thank you very much, Cindy. As I mentioned while I was Prof was still talking earlier on, the use of things like dynamic voltage restorer. I'm not good at the moment. I'll be honest with you. I'm still doing some research to when it comes to protection, but I'll do more research and use devices like, as I mentioned, DVRs, where it will assist in terms of the sags and the dips in the line, to mitigate voltage dips in the line, and harmonics, imbalances, etc., etc. So, well, I'm looking at using such to make sure that there is protection in the system.
Oh, okay, and I saw on your slides you have aims, meaning it's actually more than one. So normally, I don't know if it's how it should be. We normally have one aim, then that aim will lead or will formulate a number of objectives. So, but your own, I saw you have aims there.
I believe I've got one aim, Cindy.
Okay.
Probably maybe the issue about wedding, because I'm not sure. Yeah, probably there might be many, because maybe it's a wedding, because my aim was to explore, understand, and find solutions to mitigate this power failure. I took that as one aim, but maybe it's my wedding that makes it to look like it's a lot of them. Yeah.
Okay, okay, that's fine. Thank you very much for the presentation. Thank you.
Okay, thank you.
Okay. Thank you. Before Mr. Mbambai, what my observation is just that in integrating PV system into the grid, as we know that most of our distribution grid, they are unbalanced. They have this unbalanced problem. So definitely we're still going to face a lot of power quality issues, harmonics. So it's going to be there. But our three-phase inverter that we use to interface PV to the grid, they cannot operate during an unbalanced in an unbalanced scenario. So the use of custom devices is inevitable in this kind of research. And I'm really glad that you mentioned that, although you've not really selected the custom device you're going to use, but it's going to be crucial to the success of this research by using your PV with a three-phase inverter with a custom power quality compensating device. Thank you very much. Mr. Mbambai,
Thank you.
Can, yeah. Mr. Mbambai, you raised your hand.
Yes, thank you. Sorry, my mic was on mute. I just wanted to find out from Mr. Phakathi. You said that in the area you are doing your study, they currently have a 100 kVA transformer for 70 households. Am I correct?
Yes, about 70 years.
Okay, no, I just wanted to take note of that because it's very interesting. It would be interesting to know what the ADMD for that specific area is, because if we take it at 2.5, then it seems like the transformer is already overloaded. Although if you say it's a rural settlement, it means it might be low-cost housing. Maybe the ADMD is smaller then. But no, that's just something I wanted to mention.
Okay, maybe I can answer that because I did inquire from eThekwini. The ADMD that they are using, and indeed it's a low-cost houses, is a rural area, they are using 1.5 kVA, and that takes about 66 houses. But the way I've seen, I know it might be it's too early to mention it now. I mean, they don't really. I hope there's no one from eThekwini here. They don't really protect that. I mean, if the transformer accommodates only 66, then they make sure that they don't allow houses more than that 66, because if I remember, they're about 73, but I need to be sure. So they are probably about 8 more than what is required. So definitely it is overloaded indeed. Thank you.
Thank you.
Cindy?
Yes.
Any question?
No, thank you.
Okay. I thought raising. Okay, Mr. Ngoni. Yeah. Okay, you have the floor.
Mr. Phakathi, sorry for the noise in the background. Something is testing here. I just want to ask, what sort of questions do you intend to be asking the people? Like, I heard you said you're gonna take masks and stuff like that. What sort of questions are you gonna be asking them?
Thank you, Mr. Ngoni. What I want to establish there or to find, because the eThekwini, they mentioned this area because they told me that they've got a lot of call-outs where they are told, I mean, this area does not have power, then they have to go and find that the circuit breaker is tripped, etc. So what I need to know from the community is that how often do they have power failure? Is it during the morning, during the day? Is it evening? And then how often does it happen? Does it happen once a month, once a week, once a day, things like that? And then also to establish what appliances are they using. It's a rural area. I'm not thinking that they must be having geysers and air cons, etc., but I must not work under assumptions. I must just know from them so that I can maybe establish that this 1.5 kVA, is it still working for them or not? So it's questions around those areas, although I haven't drafted them all, but in generally, that's what I have in mind at the moment. Thank you.
Okay, thank you as well.
Mr. Phakathi, are you also going to be catering for the demand, the increasing demand? Because now you are looking at 70 houses, which is now maybe in 2 to 3 years, maybe you'll be having like 100 houses. So your installation will be mainly to sustain the people who are there now, like those 70 houses, or you gonna be adding for future?
Thanks, Cindy. To be honest with you, I didn't look for future. I see where you come from now. I'll be honest with you, I didn't look for future. I was just looking for the current challenge that they have at the moment.
Okay. Okay, thanks.
But I understand where you come from, that really we should be looking for future. We must not look for now. So, yeah, but I understand you, yeah.
No, maybe if there's enough land, because I think the land would be one of the issues, because PVs, we install them, they take, I mean, a lot of space. So
Yes.
I think it would also depend on the availability of the land. Maybe from what you can install, you can easily add the capacity to your new installation.
Okay, thanks for that.
All right. But again, I think when you're doing your installation, you should make it simple for addition. You know, you mustn't like plan it in such a way that it's only the one that you're gonna add now, and after that it's gonna be difficult for other people or maybe you to come back maybe in 3 years to come to add. You know, I don't know if you get what I'm trying to explain.
Yes, I get very well. As I'm saying that, no, I understand. Initially, I was just looking for these 70 or 72 houses, but as you are saying that there might be 10 more that are coming. So what we do now must cater for the future. So I did understand. Thank you very much. Yeah, I appreciate that.
All right, thank you.
Mr. Ngema Philani, do you have a question?
No, sir. Thank you. I have no question.
Are you sure? We still have Mr. Viren. Mr. Viren, do you have any question? Okay. So thanks so much, Mr. Phakathi, for the presentation. We're grateful for your time, and we also thank all those who participated in the questions. In the question, we're so grateful, Mr. Ngoni, Mr. Ngema, Mr. Mbambai, Mr. Phakathi, Cindy Malanda. We're so grateful for your time. And that we will conclude the meeting, and against next week we'll send a roster of how the subsequent presentations will be taking place. Thanks so much for your time. Okay, bye. Bye.
Thank you.
Thank you.
Bye. Okay, bye.
Cindy.
They cannot do it. They try it. The economy will not grow. This one that they increase fuel 162. Increase fuel, increase electricity tariff.
Most of that 16 naira, is it for per hour or per what?
Electricity.
Yes, sir.
I don't know what they are using to do.
Per month, expected bill, estimated bill.
Well, I saw there's one message I saw. It's initial one, but I didn't really capture this. It was raised from 22 naira to 66 naira.